So let's talk about parent functions and transformations. Both of those terms, parent functions and transformations, should not be new words. Parent functions are the most basic function for a family. So you know that for linear, the parent function is y equals x. You know that for a quadratic, the parent function is y equals x squared. And what we're going to focus most on this video is the absolute, which is y equals the absolute value of x. What a transformation does is it changes a graph's size, shape, position, or orientation. And the transformations are the same throughout all function families. So let's look first at the absolute value parent. And if I were to make a table, I'm going to plug in 0, the absolute value of 0, the absolute value of 1, the absolute value of 2. I definitely want to plug in negative, so the absolute value of -1 and the absolute value of -2. So if I plot these, this is the parent function of all absolute values. Now let's see what happens if we create transformations on these. So let's look at f of x equals 2 times the absolute value of x. So let's plug in those same numbers. 0 is still going to be 0. Absolute value of 1 times 2. Absolute value of 2 times 2. Absolute value of -1 times 2. Absolute value of -2 times 2. So I'm going to plot those. You can see that what I did was I took the yellow guy and I stretched him up. Okay, let's look at the next one. So -2, -1, 0, 1, and 2. Absolute value of 0 times -1/2. Absolute value of 1 times -1/2. Absolute value of 2 times -1/2. Absolute value of -1 times -1/2. An absolute value of -2 times -1/2. So let's plot these. -1, -1/2. We're going to be making a lot of tables this year, so get used to tables. Okay, so for the orange graph, it flipped upside down, and I think you probably all remember that the negative sign is what's going to do the reflection across the x-axis. Okay, we don't call it a flip, we call it a reflection across the x-axis. And you can see that it also was compressed. So I went from, whoa, sorry about that. I went from the parent, which is this yellow, to a little bit wider. So it looks like I took the yellow and I pushed down on it and pushed these sides out. That's what the 1/2 does. The 2, I took the yellow and I stretched them up. Made it skinnier, but we're going to use the word stretch. Okay, let's look at the next one. So let's look at this purple function right here, and let's see what happens. -2, -1, 0, 1, and 2. The absolute value of -2 plus 2 would be 0. The absolute value of -1 plus 2, 0 plus 2, 1 plus 2, and 2 plus 2. So let's see what happens. -2, 0, -1, 1, 0, 2, 1, 3, 2, 4. Well, where did the v go? So let's just plug in -3. The absolute value of -3 plus 2 is 1. There it is. So if I compare the yellow graph, which is the parent function, to the purple, all that happened was I shifted left 2. Instead of add 2 to the x, I subtracted 2 from the x. Last one, let's look at what happens with this bottom one. And this is very common in lines. Okay, so if you look at it, this kind of looks like the b, y equals mx plus b. So you know what b does to a line, but let's just check it out. So let's do -2, -1, 0, 1, and 2. absolute value of negative 2 plus 2, absolute value of negative 1 plus 2, absolute value of 0 plus 2, absolute value of 1 plus 2, absolute value of 2 plus 2. So negative 2, 4, negative 1, 3, 0, 2, 1, 3, and 2, 4. Now, if you're putting these all on in pencil, I'm sure by now you have a mess. So probably would recommend you go through and at least highlight over them or red pen over the, colored pen over them or something. But you can see this does the same thing it does to lines. It shifts the line up too. You can see that this does the same thing to lines. It makes the line steeper or flatter. Okay, we're going to call it stretch or compress. All right, so these are your basic absolute value functions, and then transformations on the parent function. So let's talk about what these different things are referred to. If you remember in the previous screen, this was the thing that made it steeper or made it fatter or flipped it over. So the A has two jobs. The A either reflects over the x-axis, and that's if it's a negative, or it does a stretch, or a compress. So a stretch is when A is greater than 1. A compress is when A is between 0 and 1. So when it's a fraction. Okay, H. What does H do? If you remember when we did this, what does H do? Well, H will shift my function left and right. So if this was a x plus 2, I'm going to actually go to the left. So if H is positive, I'm going to shift to the right. If H is negative, I'm going to shift to the left. So let me explain that. If I have the absolute value of x plus 2, whoops. This looks like H is positive, correct? But in the function, it's x minus h. So if this is x minus h, what did I put in for h to make that a positive? I put in a negative 2. X minus negative 2 will give me x plus 2. So if h is negative, I'm going to go backwards that amount. If h is positive, I'm going to go forward that amount. K. All right, let's look at K. What did K do? K shifts me up or down. And since the parent functions you can see are all plus k, plus k, plus k, I actually move down exactly what it says to do. So if at the end of the function it says absolute value of x plus 2, that's going to be an upward shift. Absolute value of x minus 2, that's going to be a shift down. Okay, let's go back to the green and do that also. Absolute value of x minus 2 is actually going to be a shift to the right. Absolute value of x plus 2 is going to be a shift to the left, because what I actually put in here was a positive 2 to get x minus h. This, I actually put a negative 2 in to get x minus negative 2 gives me the positive 2. So all I'd like to do on this screen is I'd like you to copy down these examples and tell me if there is an A, an H, a K, what it is, and what transformation would happen to my graph. So here would be the answers to what your A, H, and K are. Check yours and make any corrections that you need to make. So now I have a landscaper that sketches the design for a triangular shrub protector. I want to write an equation for the shrub. Okay, so if you're noticing, the vertex is actually ending up to be your H and your K. So here is the parent function of the absolute, because the parent function a would be 1, h would be 0, k would be 0. There's no stretch or compress, I don't go left or right, and I don't go up or down. Okay, so I'm going to plug in my h and k. So I have y equals a x minus, I'm going to put on my h, which is 5, plus k, which is 6. Still can't write an equation for that. I'm missing the a. I'm always, no matter what function I have, I'm going to be missing the a. So I must be able to do something to solve for the a, which means I must be able to get an x and a y from the graph. And I can see right here that I have the point 0, 0 on this graph, or 10, 0. But 0, 0 is way more easy to plug in. So I'm going to plug in the 0, 0 point. So y equals a x minus h plus k. Now I have every variable filled in except the a, so I can solve for a. So I have 0 equals the absolute value of negative 5 times a, so that's 5a plus 6. I'm going to subtract the 6 and divide by 5. There's my a value. So I'm going to go back to my original problem. So here's the parent function. Here's the parent function with the vertex filled in, with the left and right shift, the h and the k filled in. I just need to add the a. So I'm going to end up with y equals a x minus h plus k. And that would be the equation of this absolute value graph.